Alright, it's January 8th. We're back looking in the greenhouse. This is what the grow bed's looking at like now. Got the tomato plants already planted. Just planted those, put them in the ground last night. Already got the strings set up that they're going to be trained up. Cabbage that we're checking out, just something that we were given to plant. Doing pretty good there. Got about 20 tomato plants in that grow bed. Then our cucumbers are doing really good. Using a Dutch bucket system. We're actually going to be using a different nutrient solution this year in this Dutch bucket to see how it goes. Got a really good nutrient solution we're going to try, but these are looking pretty good. And the main reason we're in here is we're going to be working on the heater again. The last posting I did on this heater, I had to change to a 3.5 gallon bucket for my fuel supply with a pressurized, and over the course of a couple of weeks the bucket started leaking around the seal under the lid, and I was losing pressure. And one night the fire went out so many different times. I was getting a little frustrated having to come back out here. I've got a cold temperature alarm in this greenhouse that anytime it gets below a certain temperature, alarm goes off in the house. And I think I had to get up about 4 times that one night because the fire was going out because the bucket wasn't being pressurized right. Ended up hooking up this bigger pump down in the middle. It's actually a vacuum pump, but it'll actually produce pressure as well on the other end. And was hooking it up to it and was blowing so much air out you could hear it blowing through the seals, but I was able to get enough pressure to get the fire to go, and so I could get some sleep. So what we're looking at is we're going to be building a metal tank for the fuel tank. We're going to be modifying a portable air tank. This is just a simple 11-gallon portable air tank that we're going to modify and put some different fittings on, weld some different fittings to it, and get it set up as the pressurized fuel tank for this system. It will have a control system on it, as well as I mentioned in the last one, that as the fire goes out and the flue pipe cools down, it will shut the fuel off. And so we're going to be doing that, but right now I'm trying to figure out, okay, where am I going to put that big of a tank? It's bigger than my bucket is, and I don't want to get too close to the fire. Like right now, that plastic bucket is actually pretty close to where the fire is, but where this tank's got to go is going to make it closer, because I'm going to try to drop it down below the window. That's actually a window that bucket's sitting in. I'm going to try to drop this tank below the window so it's not able to be seen in a sight problem looking at the building. And then I don't need it too high, but looking at different options. What I'm going to do is whether I'm going to lay the tank on its side like it is or stand it up on end. If I stand it up on end, it will get up in the window. But I'm looking at possibly rotating the stove and turning it sideways, and then being able to that would give me this floor space over here where all this stuff is at, where the pump, the fan, blower, and all that's at. That would give me that much space to set that tank up. But my concern is I just put new poly on the building. If you remember the last video, you could see up the walls of the old plastic as it was collapsed. You could see mildew and stuff growing down the walls. Well, I've got Sunmaster plastic on this right now. It's a greenhouse plastic. It is inflated, and it's doing a really good job. It's I'm very impressed with this plastic. It's hard to see now because it's dark outside, but you can actually see through this during the day. Very transparent. I think it rated at a 98% light transition. So we're trying to keep from melting our walls down, and that's why I put this. This is actually a metal shelf. It's got 2 layers of roofing tiles in it. The drop ceiling tiles. Those are fire rated tiles. So it's the same material that you find behind the black panels that you buy for wood stoves at either one of Lowe's or Home Depot or places like that. It's the same exact material. So I've got 2 layers of ceiling tiles behind that black shelf, and I'm using that as a heat barrier to save my wall. If I turn this tank sideways, you can kind of get an idea of the width of it. That tank's from wall to end, it's 44 inches. So if I turn it sideways, so the tank comes out towards me from here, I've got to be able to cover 44 inches of that wall. I've got another shelf, and I can make another black shield, heat shield, but I'm just debating on different options in different ways. So we'll see how the project goes, and I'll do some shots of the build on the tank, and we'll be posting those too, and we'll see how this goes. Lord willing, we'll see you again next time. Alright, so today we're going to be converting this 11-gallon air tank into a fuel tank for a waste oil heater that is using a pressurized tank. So what we're going to do is we're going to take this tank, we're going to take this fitting off, take the valve out, take this air line off. We're actually going to flip this tank over because I need a 1/2 inch takeoff to allow the fuel to come off. This one being off-centered is not going to draw all the sludge off the bottom of the tank or any of the water, so I'll have a little bit of a reservoir under the tank. And this is already a 1/2 inch line. And I'm going to put in a 3/4 fill line. I'm also going to put in on the end of the tank over here, I'm going to put 2 fittings in with a sight tube in, so I'll be able to see the sight tube and find out how much fuel I have in here. I'm going to take this valve out and put in a low pressure valve or gauge, and then I'm going to put in an air line that'll come off that fish tank. I did a test on the low pressure gauge on the fish tank, and I'm getting about 1.5 to 2 psi of pressure off that tank. And again, it's just enough to maintain pressure the whole level of the tank. So as the tank empties, I don't reduce the flow to my furnace. And that's the purpose of pressurizing it. I needed to go to a larger tank because over a very cold night when I'm burning a large amount of fuel, 2.5 gallons was not quite enough. I was running out of fuel sometimes, depending on what time I started. If I started at 11 o'clock or filled it up at 11 o'clock, I'd run all night with 2 gallons and I'd be okay. But if I started it earlier and wasn't going to be around for several hours, by the time the morning come around, my cold temperature alarm would go off and I'd be out of fuel. So we're going to go to an 11-gallon air tank, which is about 5 gallons of oil. I'll know for sure once I fill it up. But that's what we're going to be doing, and I'll take some shots as I do some of the work. Alright, so what we've done is on the bottom end of the tank, we have scribed a circle for this 3/4 galvanized fitting, scribed the outside circle, and we measured the inside and scribed that circle. Then we drilled 8 holes in a circular pattern, and what we're going to be doing is opening that up with an air die grinder with a carbide tip. Going to open that up to be able to weld this fitting to the bottom of that tank like that. And that'll give us the ability to put a 3/4 ball valve on top to be able to fill the tank up with. And then on this 1/2 inch offset, we're going to put our gauge and our air line. So that's what we're going to do next. Alright, so we got the hole finalized, ground everything out. It doesn't have to be a perfect hole because I'm going to be welding that fitting on top. But the hole is bigger than the galvanized piece that I'll be putting on there. Now, if you notice on the galvanized, I've done ground all the galvanizing off the bottom of that piece, ground the bottom off, and it's going to be hard to see because it's so small, but I did put a crown or a reverse crown in it, so when I seat this down, it actually sits really, really flush. Looks like there's a shadow there, but it's actually pretty snug. Enough for a welder to fix, that's for sure. So we're going to weld this fitting on and go from there. Got 2 more holes to drill and the sight glass to put in, and a couple more fittings to weld, so we'll keep on going. Alright, so we've got the fitting welded on. Pretty decent little weld all the way around. I was using a 110 volt Lincoln wire welder flux cord, and that should hold up pretty good. And the next thing we're going to do is we're going to take and drill a hole up top and then another one down below. Weld these 2 fittings on with those hose barbs. I'm going to run a hose between the 2. That's going to give me my sight glass. I'm not too worried about using a hose barb with a clear plastic hose. It's actually going to be a hard plastic line, I'm only going to average about 2 psi in the whole tank, so I'm not really worried about any of the lines blowing off. If it does, then I've got a major malfunction in my design. But we're going to do that next, and then we'll just be about ready to clean everything up and repaint. Alright, so now it's January 23rd, and we finally got the fuel tank installed. The previous parts of this video were showing some of the different steps I went through. But I'm going to talk through what I've got on here. This is an old air tank, we know that. But that's my fish tank pump that I am using to pressurize the tank. Not able to get a very good image of that gauge, but that gauge is reading a little over 1 psi. So I've got 1 pound of pressure in there, and that's just enough to keep the oil flowing the whole time the tank's running, regardless of how low the fuel gets. So as I fill it the first time, right now it's empty, I'm going to put a gallon in and then take a marker and mark that hose. So I'll be able to tell how many gallons of fuel I have in here. I run around 2 gallons of fuel to 3 gallons of fuel a night. I'm expecting this tank to hold about 5 gallons. One of the things I've done with this as well is I've got a control system on it. This control box with the orange light will tell me when the system's running. Not only do I have the switch that'll manually let me run the tank, but I also have tied into that a proof of fire switch mounted to the side of the firebox. That will open the contacts, or actually close the contacts at 120 Fahrenheit, and then open them back up. I think it's like around 195. So I looked at different places to place that. First time I put it on the flue pipe, and it took forever for it to register the fire had gone out. Right here, right above the fire, it registered that the fire was out within about 4 to 5 minutes, and that's what I need, something to shut the oil off as soon as the fire goes out or shortly thereafter. What we were having a problem with, because I run this through the night and unattended, I needed some way to be able to shut the fuel off, because what would happen is the fire would go out and this thing would continue to drip. Though it would be slow, by the time the temperature in the greenhouse would set off my alarm, I'd come out here and the pot that is inside of this would be so full of oil I'd have to take about a half an hour to drain it out, get everything cleaned up and started back up. So what I'm hoping this will do and expecting this to do is that as soon as the fire goes out, within that 4 to 5 minutes, shut that solenoid off right there that controls the fuel supply, and then when the temperature of the building goes down to my alarm go off, wakes me up, I come out here, flip the toggle back switch into the manual mode, get the fire going, and before leaving the building put it down in control mode. And that's what we're going to try to do with this tank. So I hope everything was helpful that you saw in here. If you got any questions, send me a message, and I'll try to explain what I was doing here in greater detail. Thank you very much, and God bless.